So this video is to go over the proving identities. So let's look at this problem. Prove cosine pi halves minus x equals sine of x. So there are two ways to check the identities or the left side and right sides are equal in Algebra 1. First one is to plug some numbers in. Second is to graph the functions to see if those graph comes out looks the same. So that's what we learned in Algebra 1, so let's use that. So first, let's x be 0, and let's plug in here in that equation. So let's look at these two left side and right side differently. So what's cosine of pi over minus x, which is 0 now? Well, this is equal to just simply cosine of pi halves, which is what? Cosine of pi halves means that you're at the 90 degrees of the unit circle, and you look at the x coordinates. X coordinate should be 0. How about sine of 0? So when you're at the starting point, what is the y coordinates? It is 0. So in this case, it is good. So, but we know that one number doesn't mean anything. So let's plug in, let's try some other number. So how about pi halves? So let's plug in some numbers. Instead of plugging zeros, we're going to plug in this guy, pi halves. Of course, pi over pi halves minus pi halves is cosine of 0. That means the radian is 0 when you are at 0 radians. What is the x coordinate? It's 1. How about cosine of pi halves? So that's at 90 degrees. And what's the y coordinates? That's 1. So this looks good. So let's plug in another one to be a little more confident about these two. So far this equation looks identical, but I want to be a little more confident. So let's plug in another number. So how about pi? So instead of having pi halves, we just plug in pi. So pi halves minus pi is negative pi halves. Means that, well, pi halves is 90 degrees and it's negative, so you go from the 0 degrees starting point, you go backwards 90 degrees. That means it's 270 degrees. If you're there, what is the x coordinate? It should be 0. How about sine of pi? So sine of pi is 180 degrees. When you're at 180 degrees, what is the y coordinates? It's 0. Oh, okay. So it comes out the same. So if we plug in 3 numbers, everything came out the same. So we are very confident that these cosine of pi halves minus x is equal to sine of x. Another way to check the identity is to graph the functions. So we're going to graph this function separately. So we are going to graph f of x equals cosine pi halves minus x. And also we're going to graph g of x equals sine of x. So we're gonna graph that separately. So let's first look at f of x, which is cosine of pi halves minus x. So this is the graph. Let's graph another one, which is sine of x. Oh, so these two graphs looks pretty much the same. So we are way more confident now that these two functions are equal, or this equation is identically equal. But these two ways to check the identities, we are more confident about it, but we are not very confident, because no matter how many numbers we plug in, we know there's another number. So, and we don't know what happened to these equations after we plug in that number. And then after we plug that number in, we know that there's another number, or the next number. And if we plug that in, we still don't know. So how many numbers we should plug in? So there should be a way that we can plug this number in. There should be another or third way to make us completely confident about these two equations are identically equal, or identities. So let's prove this. The best way of doing this is use the algebraic manipulation. And we are pretty good at algebraic manipulations because you've taken algebra 1 and 2, and 7th grade and 8th grade you've done it. So let's look at cosine of pi halves minus x. Now for this guy, we can use angle difference formula, which is, if you remember, cosine of alpha minus beta equals cosine of alpha cosine of beta plus sine of alpha times sine of beta. So in this case, alpha is pi halves, and what's the beta? Beta is x. So we just take this guy, this formula, and we're just going to plug in those numbers. So pi halves for alpha let's just plug in, and we're going to plug in x for beta. Okay, and let's look at this. So we take this guy, So if we take this guy, we know that cosine of pi halves is the x coordinates when you are at 90 degrees. So that should be 1. We don't know what the cosine of x is. How about the sine of... Oh, wait a minute. When you're at 90 degrees, x coordinate should be 0. Sorry. And then how about the sine of pi halves? So you're at pi halves, which is 90 degrees. What is y coordinates? It's 1. So we take that. 0 times cosine of x is 0. 1 times sine of x is sine. So we started out with cosine of pi halves minus x. And that should be equal to this guy, and which is equal to the second row. And that is finally is equal to cosine of x. So that proves that cosine of x minus 2 minus, pi halves minus x is got to be equal to sine of x. And we are 100% confident that this equation is identically equal. So this equation is identical.